Alvarado here? No. Yulissa, are you here, Alvarado?
I'm here.
Yeah. Did you get your grade for me for progress
Yes.
report
Yes.
in eCampus or eConnect? You got that, huh?
Yes.
Are you happy?
Oh, thank you, Dr. Whitman.
I hope you were happy with it. I think you should too. Okay, so let me check. Naomi's, are you here? Naomi's always here, except for today. Come on, Naomi. Giselle, are you here? No. Mariella Barrios, you're here.
I'm here.
Yeah, I'm glad you're here.
I've been here. I'm always in the class. I never
You are?
miss.
You are? Let's see. I'm up from somewhere. Let's see who else. Isaiah Green, here. Brittany, are you here? No, Brittany. Yeah,
I'm
Brittany.
here.
Okay. What you? Tiffany, you're here.
Yes, I'm here.
Are you gonna watch that movie
Movie?
video?
Yeah.
Sabrina, Miss Moore. Miss Moore.
I'm here.
Are. Wonder why you don't show up on my listings here. Oh, there you are. Just kidding. Let's see, who else am I missing here? Gift, are you here? A Gift? Estrella Ramirez?
I'm here.
Estrella, are you going to stay with us now? Did I get a message from you that you're going to go to Mexico or something?
No, you didn't. I'm staying here.
You sure?
Yes, why?
Golly. That's something. Let's see. How about Elizabeth Romero?
I'm here.
Elizabeth, you the one that's leaving?
Huh?
Just kidding. April Sierra, are you here? And Daniel Ramos.
Professor, did you get me? I'm Maria.
Is that Ashley?
Maria.
Maria Apparello? Yeah. I got you.
Okay.
Good deal. Let's see. Something's not right here. Hmm. Hmm. Well, heck. Trying to figure out something. Okay, here we go. According to my book, we are supposed to be on 8.3 and 8.4. We'll move there. I spent all weekend working on your grades, and believe it or not, this is the fastest I ever graded. So for this class, everybody should have their midterm graded. Amazing. Uh-oh. You guys still there with me?
Yes. I think
Yes.
So
up
did
on
anybody,
8.1.
did anybody not get that by chance? Your test score? Thank you with that. So everybody should be good. All right, the machine's trying to push us to the book. The book is like in the slow motion mode again tonight. And I'm not sure why, but in a minute we should have, should be in a second, but it's not. It's taking a full minute almost. Like, it's not like that much. Okay, 8.1.
Yes, page 510.
510.
Yes.
Really? Perfect. Okay. So you all should be able to see the book now. Can you see it?
Yes.
Okay. So using the leading term test match, what they want you to do here, and this is a really important test question. It's easy. Notice that you have a leading coefficient for A is 3. Now, that's supposed to represent a particular graph. And you're supposed to match it to the graph. Now, the book is kind of goofy in that A does not match A matches B. So that's the question. Why? First of all, the leading coefficient is positive and it's a force, so it opens up and holds water. Look at C. It's positive, so it goes from the bottom and then goes up to the top, but it is odd, so it's got to be A. Let's see if that's so. It is. D is a negative, and it's a 6, though, so it doesn't hold water, so that's C. I mean, the leading coefficient can tell you so much, along with the exponent. I hope that number one is really important. Especially on tests, you can always get it down to 2 questions, 2 answers, probably. Example 2. You have the cube mean, and since it's positive, it starts from the bottom, as you see in the graph, goes to the top. It has some bends. Now, you can graph some of this stuff. They put in 2. If x is 2, then y is -7. Now, they have the graph skewed. The y is not the same spacings as the x. It looks like this. But what they're telling you is you can graph this a little bit by putting it in to a chart, a T-chart, and just simply graphing it. If you have a cube, you should have 3 zeros or 1. The rule is whatever number it is, the exponent, it's that number or down, you decrease it by 2. So you can see it has 3 zeros. It crosses the X in 3 spots. And if you make the X a 0, you get the Y-intercept. Notice that would be 0, 15. So number 2 can tell you a lot. I hope that makes sense. Is there any questions about number 2? All I'm doing here is plugging in numbers and graphing. Let's go on to number numeral trace. And 0 in Spanish, is that null?
Cero.
Zero.
Cero. Uh-huh.
Who said that?
Lizette?
Speak Spanish?
Yes, I do.
Sprechen Sie kein Spanish? Sprechen Sie Deutsch? Okay, find the zeros of this. Look, they've already factored it. So the zeros are 2 and -1. So at 2, it crosses. At -1, it crosses. You can see it's all they've done there. Find the zeros. If it's a cube, it's you can have x minus 2 3 times. So what makes that 0 is 2. You can't have it 3 times. Now, a little trick here. This is important. If you have a situation where you have like x plus 2 squared and some other stuff that doesn't really matter. If you have x, for my explanation, then at x, where it's -2, because that makes it 0, this graph touches there. Now, if the leading coefficient is positive, it touches like this. If it's negative, it touches like this. A square only touches. A cube goes straight through. So let's show that on our calculator. If we're saying, if that's true, let's see what happens. If you got a square, it should touch. I'm going to do x plus 2 squared. Our calculator is working. There it is. So we're going to go to y equals. And we're going to put in x in parentheses, x plus 2 squared. Close parentheses, upper arrow, square it. Push it out and hit graph. And there it is. We said it would touch, and there it does. It touches. But just to prove my point, let's make it a negative now. In front of it. Negative. Oh, let's go back. Let's see. We clear it. Down below. Messed it up. Might as well do it like it was. Okay, let's go down below. Now we'll put the negative in. Negative, open parentheses. X plus 2. Same thing. Squared. See what happens here. This will be the red one. It's your blue one. Come on, red. There's red. Touches, just like we said. So that shows you what happens. If it's negative, it doesn't hold water. If it's positive, it does. Now, we said we're going to do one other one. We're going to do the x plus 2 cubed. So let's just clear this one because it's going to get too messy. Clear that one. And we're going to see what happens with the cube. We said, back up, we're going to use open parentheses. x plus 2. This time we're going to do a cube, and we're going to watch what happens. It's not going to touch. It should cut at -2. Let's see if it does. See, there it is. It cuts through it. And that's going to happen all the time. And that's what the book is supposed to be trying to teach you. And it does a marvelous job of confusing you. At least I think so. But I'm hoping I can help make it better, because I certainly want to. I want you guys to understand this stuff, and I want to be able to show your learning. So there you have the graph right here for x. Find the zeros, this one, -2. We did that one. Let's look at 4. Now look, they have x minus 1 squared, so we know it touches at 1. We have x plus 2 squared, that we know it touches at -2, which is over to the left. And since it's negative, we know it goes down. I mean, this is all we're trying. And by the way, the multiplicity of this is 4. Now they say 3, but with a 2 and a 2, it's multiplicity of 3. In cases like this, we say the zero containing filamentous factor as a multiplicity of 3, the x plus 1 occurs one time. I don't see an x plus 1 one time. There's -1. So, they have made a mistake. The multiplicity is added. It's cumulative. 2 plus 2 is 4. They say, let's see, maybe they're talking about an example. Oh, example 3. It has a multiplicity of, 4, because it has a 3 and a 1. So, but the multiplicity, maybe they're talking about the multiplicity of x minus 2. That's a 3. The multiplicity of x plus 1 is a 1. But cumulative is x, it's 4. A multiplicity is when you add the exponents. Now, if there's a plus sign, it's the highest one. So let's be clear about this. Let's be absolutely clear. Because the book is confusing me. If I have x plus 2 squared, x plus 3 cubed, and x plus 1, first, that has a multiplicity of 6. Because you add them. But if I put a plus sign here, or a minus sign, doesn't matter, the multiplicity is not cumulative. You don't add up. It's just the highest one, and that's 3. That's what they're trying to tell you. And it sure confused me too for a second. That's the multiplicity, and that will be on the test. Remember what I just gave you, so that should be good. So this has a multiplicity of 4. I should say that somewhere. So find the zeros of this. Well, x cubed and so on. So the way to do this problem is that you group it. Now, look, they don't really show it to you, but usually it's more complicated than it shows here. I'm going to do this for you again on the side. I don't mean to be boring, but I think it's best to look at some of this stuff. By handwriting it out. So they give you this problem. They give you x cubed, they give you minus 2x squared, they give you minus 9x, and plus 18. In order to do this problem, we're going to group them. We're going to group these two and group these two. The first one we can group out is an x squared, and that's going to give us x minus 2. If you take this times this, you get the x cubed, and this times this, you get the minus 2 squared. Now, if you have x minus 2 on the left, you have to have it on the right. Minus. And what do you have to multiply 2 by to get 18? It's 9. negative 9. And you take this to test this. Does it give you negative 9 there? And it does. So your factors are this, x minus 2, and x squared minus 9. Now notice, the 9 is a square, and so is this. So this can be broken down to, since it's a minus sign, x plus 3 times x minus 3. And then, of course, you bring down your x minus 2. And you set this equal to 0, so this factor is a 2, this is a 3, this is a negative 3. That's how they did it. They grouped it. Didn't mean to go too fast. If you guys have any questions, you know, just Dr. Wickman, so you can see it here. I show you x minus 2, x plus 3, and so on. This is find the zeros, and we just did 2, negative 3, 3. What's the next one here? Hopefully it didn't go too fast. Example 7. This is a pretty cool problem because it's real world. And it's just up my alley, being in the medical business for years. So you have 0.5 to the fourth, so on. This is for how long ibuprofen will stay in your blood based on time. MTT stands for time. And so at 0, everything is 0. So there's nothing. There's no ibuprofen in your bloodstream. If you put in 0.5, you put it in all those positions, 0.5 t to the 4th, 0.5 cubed, and so on. You get 150.2, and you can test it. So after 0.5, which stands for, I think, hours, that's a half hour, you have some of this medication in your blood, causing you to have less pain, so on. Then they say how much is going to be in your blood after 1. It's 225. And 1.5 is 313. Then after 2 hours, notice 2 hours is about the peak. And then the ibuprofen starts to wear off. And after about 6 hours, it's no bueno. So some people take 2. Well, 2 just makes it stronger. It still wears off after 6 hours. Don't want to take any more than, certainly what your doctor says. Okay, yeah, if you put 6 in, this is what they call model breakdown. If you put 6 in here, you really don't get 0. You get a negative number, I believe. You can't go below the graph, especially if you put in 7. And so that's just a good thing to know. Pretty accurate about ibuprofen. Sorry. So that means if you had swelling, it would go down and you wouldn't feel the pain. Well, the problem is people used it to run marathons with and then had heart attacks. Anyway, 5 point, the next chapter is what, 8.4. Does anybody have an idea what that is? 5 something?
It's 8.2, page 519.
Yeah. 8.2. Thank you, Lisa. Has anybody here gone out to eat at all? A little bit?
No, I'm not.
No, I'm not here.
None of you have gone out? Excuse me. The shot. They announced it today. I guess Pfizer says most people hope for 60 or 70%, maybe 80%. The 90 is tremendous. Now, H, that means Y. And they have a little squiggly stuff there. The zeros of this function. Look, you can factor out x cubed. That leaves you 2x minus 3. That means you have a 0 and 3 halves. That's how you get your zeros. Whatever 0 is cubed, you get 0. 0 times anything is, notice if x is 0 for 2 times, you still get negative 3 in there, but negative 3 times 0 is 0. So this thing's going to cut through 0 and 3 halves. So now you have 0 and 3 halves. The problem with this, when you divide something up by putting 2 zeros in it, you have 3 areas. You have the area below 0, you have the area between 0 and 3 halves, and the area above it. And so you can, if the question is this, y equals this, you just put a number in for it. They're really trying to set you up for finding less than and greater than. But they're just letting you know that these are the zeros. And you can test points in there. You test for all positive values. If you put in the test point 1, it's above the x-axis, so that's positive. If you put in negative 1, it's below. And if you put in a negative 2 or positive 2, it's below. So look at this little graph right below the box. They're testing 3 points. If you look at the negative point, they tested negative 1, and they got negative answers. Put a negative in there, you get a negative. If you test 1, you're going to get a positive. So let's just do the 1 real quick. It's easy. 1 to the 4th power is 1. 1 times negative 2 is negative 2. 1 to the 3rd power is 1. 1 times 3 is 3. 3 minus 2 is 1. So, yeah, it gives you that. It's a possible solution. So there it is. Those are positive. If they're asking you which ones are positive, which one are negative, only those numbers between 0 and 2 are going to give you positive. By finding the test points. And this is what the graph looks like when they use the calculator. You can see it. These numbers like 2, negative 8, they just put them in the system to get it. 1, negative 1, negative 5. Whatever number. I mean, it's just a graph. It's an equation. You put a number for x, you get it. Not any harder. So this is a great time of year because you can invite people out for dinner and say, you really did some favor. I'll buy you up dinner. I'll take you to the restaurant. And they say, well, yeah, I can't go. Oh, okay. Well, I thought about it. And then you wait till, like February of next year when everything's good. Remember, I invited you. You haven't invited me back. Okay, I'm back. That's a bad joke. But no, really, it's, I have invited some folks out. Some of them. I go to a couple of safe places. Okay, so look at this. What is the degree of this polynomial? Anybody? You can 3. It's not multiplied. That's important. What's odd? Positive, so it starts at the bottom, goes up top. Now, the reason why it's squiggly in between because we don't know what happens in between. Now, so the next thing they do is they, what? Group it. They factor it. You look at the line, where it says 2x plus 1 times x squared minus 4. That graphs to, or factors to, x plus 2 and x minus 2. So, and in a cube, and in this particular case, you have 3 zeros. Now, cube then means you're dividing up into 4 areas. 1, 2, 3, 4. Test point -3, test point -1, test point 0, and test point +3. And so you can find out which ones will give you positive or negative answers. So look, they pick the same test points I would, -3, -1, 1, and 3. How do you get those? You get them from your brain. You look at this line right above it and you say, well, what would be the easiest number of tests to go left of -2? Well, it's going to be a whole number, and it's the shortest one or smallest one possible. It's -3. You test -100, but geez, that's a lot of work. And between -2 and 1/2, you pick the whole number, 1. That's easy. Always pick zeros. I don't know, they didn't do that. Between that, I would put 0 in. Let's see, which one did they pick? They picked 1. Let's pick 0 and see what happens. We put 0 in, you get 0, 0, 0, you get -4. So 0, -4, that's below. So instead of using 1, we use 0. It's easier. And we get, no, it doesn't work. And so on. You all see where I picked 0 here? You got whole numbers, you had a choice of 0 or 1 between a -1/2 and 2. I picked the lowest one because it's the easiest. 0. Always pick 0. The book should pick it all the time, just to help students. So do you all see what we're trying to do here? We're trying to solve these problems by finding what areas of that graph will be positive and which ones will be negative. Red in the box shows negative sign. The blues are positive. And so when you graph it, look how it graphs. Let's see, that might be on the next page. And all those areas that are positive are going to be above the x. All those that are negative are going to be below. Now, it should show that if they're going to bring closure to this concept. And there, look, here it is in the graph. We said 0 was below. I used 0, they used 1, but look, it's below. Above was between -2 and, that 1/2, that's above. And area like 3 was above, so look, that's pretty cool. You guys can do that. Okay, so now we have x4, so squared, 4x minus 16. Now, what they do for you is they factor it. They factor it as x plus 1, x minus 2 squared, and x minus 4. So they factored it for you. Now, what are the zeros? Well, the 0 is a -1, a 2, and a 4. Now, notice the square. We have been taught that if it's a square, at that position where it's a 2, it touches. If we make our x's 0, we know that's the y-intercept. So that's going to give you -16. So it's at 0, -16, it's going to cross. The degree of this thing is 4. Because it's the largest one and it's not multiplying. So we found all these things out. Now, we can find the positive and negatives here in a second, but let's look at the graph and see if we're on target. Of course, you have your calculator. You can just throw it in and be exact. You don't even have to guess, but this is just to let you know that you're on target or, in the ballpark. Again, they give you test points. And above axis was, they picked to the left of -1, -1.25. How would I do that? I picked -2. It's much easier to do -2. Between 2 and 4, they picked 3. That's sensible. Between -1 and 2, they picked 1. I picked 0. Let's go back up and look at that again. Why would you pick 0? Or let's put it in here. If you put 0 in here, 0 in here, 0, you get negative 16. So between this one and this one, where they picked 1, it should be negative, and it's below the axis, of course, because we got negative 16. Now let's see the graph. We knew that it touched 2, 0. Why? Because let's look back up here when they factored it. Well, it was x minus 2 squared when they factored this. There's your minus 16 at the bottom. 4, 0, negative 1, 0. That's the other zeros. How do you do that again? Look up above here. But let's go to the previous page. I know it's going to be so painful to go backwards, but I think it brings us again closer to this. This is really what it's all about. So when it comes to the square, it touched. So it's going to divide this thing into 4 areas because it has 3 points. Or 0. One's a touch. Right here, let's see. In fact, 1, I gave you the negative 1. X minus 2 is a square, that's what we touch. X minus 4 gave you the positive 4. You in fact have 3 points, not 4, 3. You know it's x to the 4. 3. The negative 1, 2, and 4. You know that at 2 it touches. We proved that. Go to 524 now. 524. That gets us to where we want to go. I'm glad everybody helped as much as you could each. I hope that you understand my purpose of that was learning. Why is letting him do it? Is letting you do it because he wants you to learn. I could believe. The intermediate value theorem. Let me talk about this. This is explained terribly in the book. Let me make it so easy. You have a line here and a graph. Let's say this graph goes this. Now, you have an equation, whatever the equation might be. Let's say you put this number in here, the 1. You put 1 in this equation. And you get a minus 2. So if x is 1, you get minus 2. Now, if x is 3, you get 6. So if you put in 3 here, you get minus 6, positive 6, excuse me. Notice that this one was negative 2, this one's positive 6. If one is negative and the other is positive, it has to cross the line. It can't go from this negative position to a positive position unless it crosses the line. That's all they're trying to say. If you put a negative number in and get a negative, then put a positive number in, or another number in, doesn't matter, whatever it is, and get a positive number, had to cross the line. In this case, we put in 1 and 3. 1 gave us a negative, 3 gave us a positive. We knew it had to go from here to here, and it means it cut through. And what does that mean? It means there has to be a 0. Does that make sense? So look, without making it messy. If I have a line, it goes like this. It has to have a zero because it goes from negative, negative, to positive, positive. Now, in other instances, if you have something like this, they don't have to have zeros. But the intermediate value theorem says that if you put one number in and it's negative and another number in and it's positive, somewhere in there it must cross. Does that make sense?
Yes.
I think it does. Okay, so now going back to the intermediate value theorem, they're using this. They put in a -4 and a -2 in this equation. When they put in a -4, they got -24, and when they put in a -2, they got 8. So you know it must cross. Because one turn from negative, one turns to positive. So let's see what they show. I'm hoping to show you the graph. Taking time here again, sorry. Of course it crosses. There you go. You can see A. Doesn't matter where, you can figure that out, but you know somewhere it crosses. And put in a -1. Well, let's see. Well, if you put in a -1 and you get 6, -1 here, 6 is up there. Boom, you can see it hits up there at 6. If you put in 3, you get 18. Put in 3, 18 is way up above. So somewhere between 6 and 18, you think it doesn't cross. But look, it fools you. It fools you there. So it says, intermediate value theorem cannot be used to determine whether there is a real zero between -1 and 3. Note that, that there does exist one. In fact, there are two of them. One's at 0 and one's down here. Now, let me clarify what it says here. It says there's not a zero between -1 and 3. I can't tell you if there's one, but you know that it has to have at least one. If it's a different one. If they're both the same, you can't tell. If one is negative, one is positive, then you know it has to be. In this case, you can't be sure because they both end up being the same. So the point being that if you put a number in and it comes out positive and put another number and it comes out negative, it does cross because there's two sign changes. But the numbers stay both positive, you can't be for sure that it doesn't, and this gives you an example. Now, how are you going to test it to see if there is a real zero and how many it crosses? You graph it. So it's just a little tool. I do ask you about the intermediate theorem for the test, and I'll give you a good example of what they're going to ask. But at least you should have an idea that if there is a change, a positive, negative, then for sure there is a zero. If they stay the same, it does not mean that there's not one. So, well, that's the end of that. We covered everything. I want to go over the test or the attendance. Make sure I got everybody still around. Give credit for those that are. Naomi, are you here? Naomi, are you here? Anchorage?
Hello?
How are
Can you
you?
hear me?
Yeah.
Oh, I'm good, Professor.
Did I get all your stuff?
Yes, I did send them in.
Yes. Did you get your grade?
No, I didn't. I didn't check.
You should check. You should be happy, I hope. You got the
Okay.
highest that I give for late.
Okay.
Take a look and let me know if you're happy. Let me see
Okay.
who else is, and hopefully, Yomi, hopefully you got your progress report too, all right? Did you get that?
Oh, yes, I did get that one.
Are you happy with that?
I haven't checked. I've been working.
Yeah. Let's see. Giselle? Tamara, are you here?
Yes, I'm here.
You are. Good for you. You should have been happy with your report too.
Yes, I was.
How about Ashley Martinez? Ashley, are you here? You should be. Ashley, you've never missed. Okay. Samuel Green is called in. And I think, well, let me look at on the other page. Gift, you never miss. Are you here? Yeah. The first. Yeah, are you there? No good. How about April? How about Daniel? That's everybody. Okay, you guys. Anything of me?
No, thank you, Dr.
Thank
Wick.
you.
Say
Good night.
Good night.
good night, you all. Thank
Have a
you
good
all.
night, Dr.
Appreciate
Wicken.
Good night, Lizette. Good night, Alicia. And Sherry,
Good
appreciate
night.
you. Thank you, Angela. And
night.
Good
Bye, Dr. Wickman.
night, you all. Thank you.